right, so we're looking at the College Algebra Exam 1 review. There are different versions as far as the numbers go, but all the problems are in the same order and are worked out the same way. So let's start with number 1. It says solve the following linear equation. So our variable here is t. So we're trying to get all the t's on the left and all the plain numbers on the right, and we'll add, subtract, multiply, and divide to do that. So my goal here is to get all the t's by themselves, and this t is trapped inside, so I'm going to distribute that 6 on the inside. So we're going to have 6t plus 7 equals 6t plus 24 minus 22. And we're going to combine like terms. 24 and negative 22 are like terms because they're just plain numbers. So I get 6t plus 7 equals 6t plus 2. And so I have t's on the left, t's on the right. I want all the t's on the same side, so I'm going to move them to the left. So I'll subtract 6t, subtract 6t. 6t minus 6t is 0, so that cancels out. Bring down my 7, bring down my equal sign. 6t minus 6t again cancels out, and bring down my 2. So here we see that my variable canceled out. In this case, I look to see what I have left. If it's a true expression or a true equation, then I know that my answer is all real numbers. And looking here, 7 is definitely not equal to 2, so there's no value of t that would ever make that true. And so here, our answer is no solution. All right, so looking at number 2, it says solve the following formula for the indicated variable. So here we have v squared equals v naught squared plus 2ax, and we want to solve for a. In these types of equations, or formulas as Hawks is calling it, everything that's not the variable we're looking for, we're going to view it as a number. And so we're going to solve it just the way we did up top. A is the value that I want all by itself. So everything else I'm going to look at as a number. So I need to get everything away from a so that I can solve for a. Anything that's being added or subtracted should go first. So this v naught squared, or v sub 0 squared, whatever you want to call it, it's positive, so the way that I'm going to move it over is by subtracting it. So I'm going to subtract v naught squared from both sides. And on the left, I have v squared minus this v naught squared. These are not going to be like terms because of this little subscript right here. So the way that I would write that is just v squared minus the v naught squared equals. On the left, we subtracted, so these cancel out, give me 0. And all I'm left with is positive 2ax, so 2ax. And now to get a all by itself, here looking again at what a has with it, a is being multiplied by a 2 and being multiplied by an x. So we're going to use the opposite operation just like we did here. There was a positive v naught squared, or we could say it was being added, so we subtracted it. Here, a is being multiplied by 2 and x, so the opposite operation would be division. So I'm going to divide both sides by what a is being multiplied by, and that's 2x. So on the left, I'm multiplied by 2x, now I'm dividing by 2x, so that 2x will cancel, leaving a all by itself. So I can now say that a is equal to v squared minus v naught squared all over 2x. There's the answer. All right, moving on to number 3. We're asked to solve the following absolute value inequality and express our answer in interval notation. So remember, when we take the absolute value of a number, what we're finding is its distance away from 0. Since absolute value is measuring distance, that indicates that every time we take the absolute value, we should get back a positive number or 0. So keep that in mind when we go to solve this. In solving an absolute value equation or an absolute value inequality, your very first step is to always get the absolute value by itself. I see here that 8 is being multiplied to the absolute value, so to get rid of that, I'm going to divide both sides by 8. So my 8's cancel here on the left, so I'm left with the absolute value of 1 minus y is greater than negative 24 over 8. So that simplifies to negative 3. And now once I have the absolute value by itself, regardless if this is an equation or an inequality, I want to stop and think, does this make sense, or what does this actually say? So this says we took the absolute value of something, right? Y is a number, so this is going to give me back a number. We took the absolute value of something, and it gave me back a number greater than negative 3. Well, we just said when we took the absolute value of anything, it should give me back 0 or a positive number. So think about, what could I take the absolute value of that's going to give me something greater than negative 3? And the answer is anything. I could take the absolute value of anything, and I know it's going to be greater than negative 3 because of the way absolute value is defined. So I don't even have to go any further from here. I know that I could take the absolute value of any number and make this true. So my solution, written in interval notation, since it's any number, that means I could go all the way down to negative infinity and all the way up to positive infinity. And no matter what number I pick, when I take the absolute value, it will be greater than negative 3. So my solution here for number 3 is negative infinity to positive infinity. Now let's pretend for a second that it had been, instead of greater than, it had been less than. So we pretend we had 1 minus y, the absolute value of that is less than negative 3. So again, don't look at all those problems, but we have the absolute value by itself. And now this time it says that we took the absolute value of a number and it gave me something less than negative 3. Now we know when we take the absolute value of a number, any number, it's going to either give me 0 or a positive number. So is there a number we could take the absolute value of and get something less than negative 3? And the answer is no, because the numbers that are less than negative 3 are just more negative numbers. So when we take the absolute value, we'll get something positive. So in this instance, there's no number that I would take the absolute value of that would give me back something less than negative 3. So this one would be no solution. So just being able to read what your equation or inequality says. All right, so number 4, it's a fun triangle problem. We're given these 3 coordinates, and it says determine whether or not the given points form a right triangle. If the triangle is not a right triangle, determine if it is isosceles or scaling. So we want to determine first if it's a right triangle. And so remember, if it's a right triangle, then a squared plus b squared equals c squared should hold true, where c is the longest side. So we need to determine how long each side is, which means we need to find the distance between each set of coordinates. So we need to do the distance formula 3 times. So let me scoot that up. All right, so let's start with the first pair. We'll start with 1, negative 5, negative 3, negative 6. And remember that the distance formula is the square root of x1 minus x2 squared plus y1 minus y2. This will squared. This will tell us the distance between these 2 points, which tells us the length of that side of the triangle. So these are coordinates, so I'm going to let this be x1, y1, x2, y2. It helps if you label so you know where to put the numbers. So we'll have the square root of x1 is 1 minus, because that's part of the formula, x2 is negative 3 squared plus y1 we put as negative 5 minus, again that's part of the formula, and y2 is negative 6 squared. And now we'll simplify that. So a negative and a negative make a positive, so that gives me 1 plus 3, which is 4, and 4 squared will give me 16, plus, again, a negative and a negative make a positive. So -5 plus 6 is +1, and 1 squared, or 1 times 1, is just 1. So the length of this side is the square root of 17. So now let's pick 2 more coordinates and we'll do it again. So let's do 1, -5, and the last one. How about that? So we're going to find the distance of 1, -5 and 5, -6. And again, I'm going to do a little labeling so I know where to put the values. So I have d, my distance, equals the square root, again, of the x1 minus x2 squared plus the y1 minus y2 squared. So x1 is 1 minus x2, we define to be 5, or we labeled as 5. y1 is -5 minus -6. And again, we'll simplify. 1 minus 5 is -4, and -4 squared, that's -4 times -4, which gives me a +16, plus a negative and a negative make a positive. -5 plus 6 is +1, and 1 squared gives me 1. Ooh, so again, we have a distance of the square root of 17. So we know that these two side lengths are the same. So let's look at the third side length. We did the first two, the first and the last, so that leaves the middle and the last coordinate. So we need to find the distance of these. So we're using, let me come down here. We have -3, -6, and 5, -6. Let me scoot that up there where you can see it. 5, -6. And same thing, just the distance formula. So distance equals the square root of this right here, x1 minus x2 squared plus y1 minus y2 squared. And again, I'm going to label x1, y1, x2, y2, so I know where to put them. So x1, -3 minus x2 is 5 squared plus y1 is -6 minus y2 is -6 squared. And we'll simplify. -3 minus 5 is -8, and -8 squared, or -8 times -8, gives me +64. A negative and a negative make a positive, so I have -6 plus 6, which is 0. 0 squared, or 0 times 0, is just 0. So I have +0. 64 plus 0 is 64, and the square root of 64, that's a pretty square root. What do we multiply together? What do I multiply by itself to get 64? And the answer is 8. So this side ends up being the square root of 8. So we could stick this in the calculator. The square root of 17 is going to be about 4 point something. So I know that this side is the longest side. So I'm going to put that into the Pythagorean theorem. A squared plus b squared equals c squared, and see if it gives me a true statement back out. So again, 8 is c, so that makes a and b the square root of 17. So a squared plus b squared equals c squared. So we have the square root of 17 squared plus the square root of 17 squared equals, we said that 8 was the longest side, so that's c, 8 squared. So the square root of 17 squared, when we square a square root, these are inverse operations, so they cancel out. So this gives me 17 plus, likewise here, the square root of 17 squared is going to cancel out and give me 17. And 8 squared is 64. So 17 plus 17 is 34, and we know 34 is not equal to 64. So what that tells me is this is not a right triangle. All right, so let's go back. It says determine whether or not the given points form a right triangle. The answer is no. If the triangle is not a right triangle, determine if it is isosceles or scaling. So scaling is going to be a triangle where all 3 sides are different. And we see that we do not have that because we have 2 sides that are the same. 2 sides that are the same, which tells us that this is isosceles. This isosceles triangle will have 2 sides that are the same length. And so we do end up having an isosceles. So for step 1 is B. It is an isosceles triangle, again, because we have these two side lengths that are the same. All right, so what is the area of the triangle? Hint, make use of the midpoint formula if the triangle is isosceles. So let me draw a picture real quick. So I'm going to go ahead and plot these points on a graph so we can get a better idea of what's going on. I have 1, -5, this point right here, -3, -6, and 5, -6. There we go. And so we know that this side is the square root of 17, this side is the square root of 17, and this side is 8. And we want to find the area of this. The area of a triangle, remember, is the base times the height divided by 2. So we know the base, that's what it's sitting on, this piece right here. And so I want to find the height. The height is going to be from that point down to the base. So to figure out what that height is, I need to know what is the distance between this point, which we know what that point is, we just plotted it. That is 1, -5, and this point right here. Now in order to find what this point is, this is dead smack in the middle of these 2 points. So I need to know what is the midpoint of these 2 points right here, and those 2 points are -3, -6, and 5, -6. So to figure out the midpoint of those, like I said, we will use the midpoint formula. And the midpoint formula just says we're taking the average of the x values, average of the y values. So that's x1 plus x2 over 2, and then y1 plus y2 over 2. So to find the midpoint of any 2 points, or the point in the middle of any 2 points, we just add the x's, divide by 2, add the y's, divide by 2, and we'll have our midpoint. So my x's are -3 and 5, so -3 plus 5 over 2. And my y's are -6 and -6, so -6 plus -6 over 2. And let's simplify. -3 plus 5 gives me 2. You can't see that. -3 plus 5 is +2, and 2 divided by 2 is 1. -6 plus -6 is -12, and -12 divided by 2 is -6. So here we have the midpoint. So this point right here is 1, -6. And to get that height, we need to find the distance between these 2 points. So we get to do the distance formula one more time. And so again, square root of x1 minus x2 squared plus y1 minus y2 squared. So my x values here we see are the same. So I'm going to have 1 minus 1 squared plus the difference of my y values. So -5 minus -6 squared. So let's simplify this. 1 minus 1 is 0. 0 squared is just 0 plus a negative and a negative make a positive. So -5 plus 6 is 1, and 1 squared is 1. 0 plus 1 is 1, and the square root of 1 is just 1. So we know that the height is 1, the base is 8. So plugging that into the area formula, we have area is equal to base, which we said was 8, times the height, which we just found to be 1, and that divided by 2. So 8 times 1 is 8, 8 divided by 2 is 4, and there we have the area of this triangle is 4. So come over here. What is the area of the triangle? It is 4. All right, so let's move on to number 5. Scoot that up. So it says, consider the following equation. We have 8y minus 72. We want to find the x and y intercepts if possible. To find the x-intercepts, we're always going to plug in 0 for y and then solve for x. And to find the y-intercepts, we'll always plug in 0 for x and solve for y. So to find my x-intercept, I'm plugging in 0 for the y value. So let's do that. We're finding the x-intercept, and I'm going to plug in 0 for the y value. So 8 times 0 equals 72. And 8 times 0 is 0. And again, here my variables went away. I don't have an x to solve for, and we see here that this is not a true statement or a true equation. 0 will never equal to 72. And what this indicates, we were trying to find the x-intercept, so I know that there is no x-intercept. Generally, we would say none for x-intercept. I think Hawks asks you to write absent. So to be consistent, my x-intercept is absent. We do not have one. Now to find the y-intercept, we plug in 0 for x and solve for y. But again, if you look at my equation, I don't have an x value. So what does that indicate about the y-intercept? So let's take this thing real quick, 8y equals 72, and let's solve it for y and talk about what that means. So to get y all by itself, I'm going to divide both sides by 8. So I get y is equal to 9. Now I don't have an x value, and what that means, or an x variable, y is equal to 9. That's it. It doesn't matter if x is 5 or x is negative 52, if x is 1,475. Y is going to be 9. This type of equation gives me what we call a constant function, right? Because this is constantly 9. So let's look at this graph real quick. When x is 0, what's y going to be? The answer should be 9, because no matter what x is, y will be 9. So here's 9, and what that tells me, that's my y-intercept. When x is 50, what is y? And that should give me, it's going to be 9. When x is negative 1,742, y is still going to be 9, and what that creates is a horizontal line. So anytime you are presented with an equation or a linear function that simplifies to just y equals a number, know automatically that you're going to have a horizontal line that crosses through whatever that y value is. So in this case, y is 9, so it crosses through this value right here where y is 9. So that tells me that my y-intercept is 9, or 0, 9. So my y-intercept, my x-intercept I don't have, but my y-intercept is 0, 9. So my x-intercept, like I said, they want you to say absent, and my y-intercept is 0, 9. All right, so graph the equation by plotting the x and y-intercepts. If an intercept does not exist or is duplicated, use another point on the line to plot the graph. So we did essentially just do that, but let me run through that one more time. We know that y is equal to 9. We just solved it. So I could pick any x value I wanted. So coming up with more points here isn't going to be so bad. I could pick any x value, and I know that the y value I get back out is going to be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 0, 9. I could pick 1, 9, 2, 9, 3, 9. We could give them as many points as they wanted, but it's just going to be a horizontal line right there. Okay, so there is number 5, step 1 and step 2. And I'm going to stop right there because this video is getting really long, and I'll start a new one and start with number 6.